welcome to the HSC Maths Advanced April 2023 lecture. My name's Krisha and I'll be taking you through today. Before I get started, I'd actually like to give a massive shout out to you guys. Congratulations on getting through your halfway point in your HSC journey. That is a massive achievement in itself, and also a big thank you for you guys for just joining in today. The fact that it's the middle of your holidays and you've got the motivation and dedication to like actually get onto your computer and come to this lecture um, is a big thing. So thank you. So I am from ATAR Notes. So I'm just going to tell you a little bit about ATAR Notes as a whole. So we've been around for a while, and we had in-person lectures running from 2016 to 2019. Then something called 2020 came along, and we started off with our live streamed online lectures, which were going quite great. But this year we've had a little bit of a decision to try and mix it up a bit. And we're doing pre-recorded lectures this time. So I am not speaking to you live at the moment. I'm speaking from a few days back. But we've still got a live Q&A going down the bottom. So any questions that you do have, I'll still be there. I just won't be answering it live through this session. I'll just be typing in my responses to your questions. So any questions that occur throughout the presentation, may it be related to what I'm talking about or related to study or the HSC or uni or life, still pop them all down below. I'll be answering them all just in the chat. Okay, a little bit more about ATAR Notes is that we have a drive to help as many students as possible. So we have a bunch of free resources for you guys. One that you guys would hopefully already know about is our online lectures. I think it's one of the things that we're most known for, as well as like through our website, you can find our study notes, forums, like study videos, our monthly newsletter, the ATAR calculator, which we're also quite known for, and a bunch of other things as well. On top of this, we've also got some other resources that aren't free, which include TuteSmart, which is the program that I'm under. I am a Maths Advanced tutor for TuteSmart, so I won't speak too much about it, but it's basically ATAR Notes version of tutoring. We have 90 minutes of like classes via Zoom each week. For Maths Advanced, it's Mondays 4:30 to 6 o'clock. I'd highly recommend joining. We've also got our study guides, which is probably the thing that we are most known for apart from our lectures, those ATAR Notes books. And then we've also got N Unlimited, which is pretty much all the study guides that we have put onto a website that you pay like a monthly prescription for, which is pretty much like Netflix before the HSC. I'd also highly recommend. I also used it when I was in year 12. Okay, I'd also like to give a massive thank you to our university sponsors, including La Trobe University and Macquarie and UTS as well. Without them, these lecture series wouldn't be occurring. So massive thanks to them. Okay, so let's get started with what we're going to be doing today. We're going to start out with just a nice little poll down the bottom, seeing how you guys are going. Then a little bit on some Q&A, followed by how you can actually achieve the marks that you want and how you can, go about questions to maximize marks as well. And then we're going to be going through a few things, including graphing and, oh my gosh, graphing and financial mathematics. I am completely gone in the brain today, sorry. Okay, so a little bit more about myself. I graduated in 2021, so a year and a half ago approximately. The subjects that I did include Maths Advanced Extension 1, English, Physics, Chemistry, and Design and Technology. I had an ATAR of 95.85. Currently, I am in my second year of vet science, and obviously, with the name of my degree, You can tell that I'm a bit of an animal fanatic. I do love to rescue and foster animals. I currently have a cute little foster kitten at home. He's just downstairs at the moment. If I brought him here, I wouldn't be able to do this lecture because he'd be trying to like eat my computer away. So unfortunately, you probably won't be seeing him today. But yes, I do love to rescue and foster a bunch of animals. And another fun fact about myself is that I love rock climbing, but I really can't say that I'm any good at it because I just don't have the strength for it, but I still enjoy it. Okay, so a quick check-in. I've got a slider pull down the bottom that's just got just a few questions that I want you guys to fill out. Obviously, I won't be going through anything live because you guys aren't here while I'm recording, but yeah, it's just for you to do a little bit of self-reflection. I'll give you a couple minutes to do that. Um, Okay, feel free to pause this video whenever you'd like to actually work through questions or finish slider polls on your own, because just so that it's not a bit weird because it's all a recording, I'm not going to give you that much time to actually work through things. It'll be more like, okay, I'll give you a few seconds, pause the video, and work things out by yourself. That's mainly how this like lecture is going to go. Okay, so let's get started. So the actual game plan. Oops, game plan. Frequently asked questions followed by basically marks maximization, followed by section one, which will include graphing, so sketching functions. So it'll be really nice and easy for the first section. Second section, I can't say the same thing. It's going to be financial mathematics, which is the bane of most HSC students' existence. So we're going to start with sequences and series, and then we'll try and work our way towards financial mathematics as well. Cool. And we will be practicing on real questions that have appeared in previous HSC and trial questions. I won't be using any HSC 2022 questions just so I don't ruin all of the questions that you could do in like future past papers. But yeah, just something to keep an eye out for. Sorry. So frequently asked questions that I get pretty much every time that I have lectured is number one, how much time should I spend studying for maths, or how much time should I spend studying altogether? Um, there is no way to properly quantify the time taken for studying. The way that I would study would be different to the way that you would study, which would be different to the way that the next person watching my video would be studying. So what I personally did is I'd have a set goal for what I wanted to get done. So I would I still use it even at uni. So I have like, you guys can't see this on the camera, can you? There you go. Kind of ish. You're gonna like put out your subjects that you want to study in for the day. If you're not too sure which subjects to study for the day, then you can make some kind of timetable for like block out 2 or 3 subjects and blah blah blah. Um, but yeah, what homework do you have? Start with your homework and then build up. Oh, I should keep on top of my study notes. So I'm going to do that for English. For maths, I am kind of struggling with financial maths. It's kind of disgusting. I need to spend more time working on it so that I am more confident in it. So it's more so goal orientated working rather than time orientated. But a general rule of thumb for studying altogether that I know teachers like to use is you should be studying approximately 3 hours a day. Um, so yeah, take that however you would like to. Um, what did studying for maths look like for you? For me, it would look a little something like I'd get home. I would first take like a break because school's enough already. And then I'd do my math homework. So whatever homework I had for maths, I'd get it all done. Then I'd obviously mark. Whatever I got wrong, I would reflect upon what I got wrong in my homework and be like, why did I get that wrong? Is there anything that I can do in future questions like this to stop making that problem? Then I'll see if I can source a question that's similar to the type that I got wrong, unless it was just a silly mistake. If it was a silly mistake, kind of just still work out what you made that mistake in so that you know next time, oh, for the 100th time, I've mistaken the quotient rule for the product rule. Um, and just keep that in the back of your brain, because if you know what you did wrong and you actually, take a second to be like, oh, then the next time you go about a question like this, it'll be more so in the back of your brain that, oh, don't make this mistake. We made that last time. Let's fix it by using the right rule this time. So just that actual mental reflection. And then I would go about probably not so much on the weekdays so much, but on the weekends, I would spend a good chunk of time doing maths. So that would be probably my at the very least half of a Sunday. So maybe like from 9 a.m. to 1-ish, I would do maths advanced and a little bit of extension one, or vice versa, whichever one I was feeling like doing more. And that would be the time that I spend going through things, even all the way from year 11, that I'm not super confident in. So financial maths being one of them that I wasn't really good at initially. Another one that I did was like perms and comms. Oh, sorry, that's extension one. But something that's disgusting from like year 11, it's really good to just keep going at it through like consistently so that you don't forget how to do it as well. Okay, I'm spending a lot of time on this one question. I'm going to move forward. What should I do if I've just lost motivation and I'm not seeing any progress in my efforts and marks? That's a really good question, which I get a lot of the time. I will have like a halfway checkpoint in between this lecture where I'll go a lot more into this, but please make sure that this holiday time, you're spending a fair chunk of it as a holiday. So take at least a couple of days this holidays not to do anything. So don't do anything school related. Don't touch your laptop even. Just relax. Because just getting that taste of nothing will really rejuvenate you and hopefully bring back your motivation. But I will spend a lot more time on like building up your motivation again a little bit later on. Okay, I'm putting in a lot of time and effort to keep up with my class, but my results aren't reflecting this. What should I do? This is such a devastating spot to be in because I feel like most people can relate to this question. Um, and the best advice that I could give you, based on my own personal experience, is you're putting in the efforts, you definitely are, but maybe the way that you're going about your study or about like what you're trying to do isn't the right method for you. So just because Sandra over there makes like her nice little study notes that look really aesthetic, and that works for her, she's getting her A+. For someone like me, making study notes won't work. I could obviously do it, but it's not going to actually do me any good for the way that my brain actually understands stuff. I need to do stuff like active recall or like speaking things out. So learning the way that works for you would be really, really good. And about now is a really good time to start um, like exploring that so that you can um, get on top of your actual marks, because you're definitely already putting in the effort. You're putting in all the work, and you're just not getting the outcome that you need. So try shifting your work in a different way and hope that that will make things better. Okay. Last question. I know all the techniques and content, but I am so prone to making silly mistakes. How can I fix this? This is once again probably something that everyone could relate to. And there is actually a method that I didn't make up. I actually got this from like the 800s lecturer person before me, so the person that lectured me. And I started using it. Like initially, I was like, this is like such a dumb long list. But once I started actually putting it into practice, I like actually saw results. So let me let you in on the secret. It's a little something called framing. So framing is just a 4-step way to go about a problem or a question more so. So let's take a look. So the first step is to actually understand the question. Read it again. Okay. Now you're going to first take a look at the actual key variables. So what would your X be, or your Y be, or your A, R, N, whatever the variables are, point them out and be like, X is equal to this, Y is equal to this, when blah, 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 then blah, blah, blah. Whatever the question says, write it down in your own, like the way that your brain will best comprehend it for the question. What's the second thing is to look for the hidden given information. So, sorry. One would be what like a question that would be like, what is the least number of people that Bobby could have on his bus be? And it's got some kind of equation. Then you're probably going to be looking for a minimum turning point. So number one, we're looking for stationary points, and number two, we're looking for it to be a minimum stationary point. So something like that. Find out what that hidden information is. So from the least number to minimum stationary point or minimum turning point, that's two completely different things like in your brain. So just keep that in mind and kind of write that down for yourself. Third thing is, what does your final answer need to look like? Does it need to be, well, first off, is it actually a number, or is it like a show that question or a prove that question? Do I need to have units? If so, what are my units? Do I need to round to significant figures or anything like that? Keep that all in mind. Next step is to recall relationships formulae. And you're going to just, number one, write down those relationships or formulae, and then you're going to step three, solve methodically. Okay. Once you've done your whole solving, you're going to check for three things. So, number four, you're first going to check that your answer actually makes sense. So, all info makes sense and is actually correct. Number two, the formula that is written correctly. If that formula that you found in step two is in the formula sheet, I would, even if it was the easiest question and it was like, I don't know, the product rule or something, I'd go to my formula sheet and I'd find that equation and I'd be like, yes, I wrote that down exactly as I needed to. Just because in the HSC you might make a mistake. So check that the formula is correct and that each line of working underneath it is also correct, and that you've made no mistakes. So this is framing. I know it looks a little bit complex, but once you start doing it, it's literally like it doesn't take any more time than it normally does to answer a question. Pretty much the only difference is question like one and not question, steps 1 and 4, where you're actually making sure that number one, you're answering the question, and number two, you're doing everything correctly so that you can get the full marks. So really there's nothing to lose in this one, this like little method. So I'd highly recommend. Okay. Another study technique, I suppose, would be mind maps. So I personally started using mind maps a little bit later in my HSC journey, maybe about where you guys are at the moment. And it's really good to like summarize what you're learning, especially for HSC Maths Advanced. So you've got like your, I've actually got a picture. Well, this is one version, but something like this, where we've got calculus in the middle, and then you can branch off to like differentiation, and then integration, and then applications of differentiation, and blah blah blah. And then from differentiation, you could like branch out to this, and that. And then from those branches come more stuff. So the hierarchical map is another way to do it if you don't want to actually draw bubbles and stuff. But it's a really good way to just link all your information together. So I would also highly recommend. Okay, so let's actually get started with today's content. We're going to get started with sketching functions. So take a seat, get your cup of tea. It's not going to be too bad for the first half because I feel like this is all recap from like year 10. So that'll be quite nice. Okay. So sketching functions, is truly is the backbone of the HSC Maths Advanced or even Maths Standard. And it's a topic that I really hated for a long time until stuff like financial maths came along, and I was like, okay, this is sketching isn't that bad. Um, so you probably will be asked to sketch a graph, but you do need to know how to check um, like how to actually sketch graphs, partially because there's a chance that you will be asked to sketch a graph in the HSC, but also there are a lot of times where sketching the graph is going to actually get you the correct answer, whether or not you're actually marked for sketching it, um, which might not make sense yet, but we'll get a few questions in a few slides that will kind of get you there. Oh my gosh. Okay, so how do we actually graph a graph? So there's three simple steps. So first we're going to find the x and the y coordinates and plot them to join the like like a dot to dot curve or line. It kind of works. It is very time consuming and sometimes you might miss the actual point of the um the actual points of turning the actual turning points and stuff. So it's an okay method. The other method is translations and dilations. So you know the actual shape of the curve and you can like move it this way, 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 this way. Um, and then the third way is through finding the first and the second derivatives. The third way we will not be going through this lecture. You'll have access to the January lectures, however, when I did go through this. So if you're not sure how to do it, or if your class is like now started doing differentiation and you want to recap all that stuff during the holidays, highly recommend go to the January lecture. Okay, so um, oh my gosh, why does it keep doing that? Okay, so what is necessary to have in any graph? So let's say we have like a 5-mark question and 1 mark will be allocated towards just the actual presentation of the graph. By that, I don't actually even mean the shape of the curve or anything. I'm talking about the requirements to just get everything. So they include the labeling of the x and y axes as well as the origin. The intercepts, if there are any, should also be shown. Um, the equation of the graph should also be labeled as seen over here. And we need an appropriate scale. So that doesn't necessarily mean that your x and your y need to be the same, but your x and your x needs to be the same. And the y also needs to be the same. So an example of what I mean by what you shouldn't do is, let's say we have like -2, -1, 1, 2, 3. And then on this side, we've got like 1, 2, 3, and this is like -100, -1,000,000. Okay, that's 100 million. Never mind. But yeah, you see the point, right? There is no actual uniformity with the x-axis, which you need to have. So something else to keep in mind. If you don't have any one of these 4 things, you will not get full marks in your question. So if you accidentally forget to label your x and your y axes, I'm really sorry because you just lost a mark for not labeling them. So this is something that I want you guys to get really comfortable doing now whilst you're still like getting used to drawing graphs so that you've formed a really good habit. Okay, so let's go into the translations and dilations. So just a pro tip about studying for the HSC. You don't necessarily need to know every single dot point in the syllabus, but you should study from the syllabus. So if your school was anything like mine, especially for maths and chemistry, I had teachers that were super duper passionate about maths or chemistry. And they'd teach you a lot of stuff that wasn't necessarily related to the content, but just because they love that kind of stuff. So, sorry. Oh, it's bad when I'm losing my voice already half an hour into the lecture. Sorry, but yeah. So just so that you actually know what is required of you guys to know, the syllabus will tell you everything. Nessa can't teach you anything that's not in the syllabus. So the syllabus is your best friend. Would recommend studying from there. So you can see that there's actual like dot points and the kinds of graphs that you can actually like graph as well. So everything required is there for you. Okay, so let's go into translations. Translations is basically moving a graph. So literally, we've got our parabola example over here. Um, Here's our parabola. We can move it up or down. We can move it left or right. Okay, that's what I mean by a translation. So when we're moving a graph up or down, um, we can add c to it. So y is equal to f of x plus c. C can be any number from negative infinity to infinity, but the direction or the value of c is something that matters. So if c is positive, the graph will be translated c places up. If c is negative, it'll be translated c places down. And that is pretty much all to it. So I'm going to give you a second to try this on your own. So draw y is equal to x squared. And then on the same graph, draw y is equal to x squared plus 5, and then x squared minus 4. Yeah, okay. You'll probably need a little bit more time than this. So what I'd recommend is just pausing this video and graphing the rest of your curves. Please remember to actually try and incorporate the 4 things that I was talking about in the previous slide that are going to get you your full marks. So definitely something that I want you guys to get used to now. Okay, so this is what your curves will look like. I'll give you a second to try and see what am I missing in these curves that's going to stop me from getting full marks in if this was like a HSC question. I'll give you a few seconds to think about it. If you made notes on what I did like 3 slides ago, you'd be able to point out quite a few things. Okay, I'm going to assume that you guys know now. So, stuff that I have not incorporated includes my x and my y axes labeled. My origin is already labeled. I need to have my intercepts labeled. So this one's nicely labeled, this one's nicely labeled, but this one over here, I just need to write it's -4. I also have my x-intercepts labeled. I've only got 2 x-intercepts, and luckily for me, y is equal to x to the x squared minus 4 is something that I can figure out the intercepts for. So let's figure it out. The way that we can figure out our intercepts is by making y equal to 0. So y is equal to x squared minus 4 is equal to 0. X squared is equal to 4. So x is equal to plus or minus 2. So this over here is minus 2. This over here is 2. Awesome. Now what else is left? I need to actually label my curves. So in the blue, we have y is equal to x squared plus 5. In the red is y is equal to x squared. And in the green, we have y is equal to x squared minus 4. Okay, awesome. Perfect. Okay, now let's move on. The other kind of translation that I was talking about before was left and right. So that can be seen for the notation y is equal to f of x plus b. So I want you to take a look at the actual notation. You can see that we've got it inside the brackets of the function, as opposed to y is equal to fx plus c. Y is equal to f of x plus c. The way that I remember which variable is being impacted by these translations is by actually looking at where the like B and the C actually are. So if you take a look at your C over here isn't actually inside with f of x the same way that B is. So C, if it's not related to x, it would need to be related to y. So it's outside the brackets, it's related to y. In this same way, our b is in the brackets with with x, which means that it needs to be related to x, right? So it's not really dependent on the y. So b is horizontal translation, whilst c is a vertical translation. For many of you guys, this would be very simple stuff, but I just want to make sure I go through this for someone that might not be super confident with this because we've got a whole range of people with us today. Okay. Now the actual impact that B has on the translation. So B can, as I said before, moves it left to right. So B can take any real number, ranging from negative infinity to infinity, just like C. But the actual value is kind of counterintuitive compared to C. C is pretty easy. It's like if C is positive C, then we're moving up C places, right? In this case, if B is negative, then we're moving to the right by B places. And if B is positive, then we're moving to the left B places. Okay, so right is negative, left is positive. The way that I remember this, it'll come a bit more handy even when we go into our dilations, is that X is always counterintuitive. Whatever you think it is, chances are it'll be the opposite. So if something is negative, typically you're wanting to go left because left goes to negative sides. But no, we're going to the positive direction. We're going right. So just something to keep in mind because I'm gonna go through that idea in a few slides again. All right, awesome. So now another graphing example. Draw y is equal to x squared. And on the same graph, draw y is equal to x plus 2 squared and x minus 4 squared. I'll give you a sec to draw that on your own. Please try and include the 4 things that are in a good graph. Okay, I'll give you a few seconds to pause if you aren't done, and we'll move on. So let's take a look. This is what our final answer will look like. Once again, I'm missing a few things in my response, so let's go through this. I should put arrows on all my curves. Tis a standard. I should label my axes and my origin. I should label my intercepts. Luckily for me, the intercept's already labeled really nicely. What else do I need to do? I need to actually label my curves as well. So let's take a look at these graphs. So y is equal to x plus 2 all squared. That means that x plus 2, b is equal to 2. So, well, positive 2, let's keep that in mind. Positive means we're going in the left direction, okay? So if we're going left and we're going 2 places, our intercept will be x is equal to -2. So this blue curve is y is equal to x plus 2 all squared. Y is equal to x plus 2 all squared. Our red is our original y is equal to x squared. And now let's take a look at this one over here. Our b is equal to -4. B is equal to -4. Um, so B in this case is a negative number. Negative means we're moving to the right. And by how many places? 4. So our new intercept for x will be at x is equal to +4 because we're moving 4 places to the right. Luckily, the intercept's already written down, which shows that the green graph is our final answer. So y is equal to x minus 4 all squared. And that is everything required to get full marks for this question. Awesome. Okay, now we have something that I suppose is a little bit more annoying. It's something called a dilation. So a dilation means that the graph is either expanding this way, or contracting, going inwards. So let's take a look. Okay, so when we are doing a contraction or expansion, we have two options. So y is equal to k times f of x, or y is equal to f of kx. Now this is a little bit different to your normal examples, because I'm not sure, let me check. The example given won't really go into this too much, but we will go through like proper examples later on. I'm actually going to change the value of k over here to a, just to make your lives a little bit easier. So let me go through k first because k is correct over here. So k is a vertical dilation. So the curve, whatever it may be, is being stretched by a scale factor of k. K can be any real number, just like C and B, sorry, between negative infinity to infinity. K means that the whole curve will be expanding slash contracting. It'll expand if K is, mm, yeah, okay. It'll expand if K is between 0 and 1, or even more so between, if the absolute value of k is between them. It'll contract if k is greater than 1, and it'll flip over the x-axis, so it'll become negative if k is negative. Now let's take a look at a, because a is like the complete opposite of that. Basically, if we're impacting k, we are making it become super long. If we're impacting a, we're changing its width. So let's go through this. Okay, a can also take up any number, and it will expand or contract the curve using the x sides and not the y sides. It will contract if k is between 0 and 1. I'm going to write it as -1 to 1, because any of those numbers, the absolute value of k will be less than 1. It will expand if k is greater than 1, and it'll flip the y-axis. Oops, why am I writing k? I should be writing a. Sorry for anyone that's copying. It'll flip the y-axis if a is negative. Okay, so instead of flipping the x-axis like before, we'll be flipping the y-axis. So let's say we have our original curve looking like an exponential. Our new curve will look like this. Okay? So with that in mind, this example, you can choose which one you'd like to use, A or K, and answer these parabola questions. So using the same correct techniques necessary to get full marks in your graphs, draw y is equal to x squared, and on the same graph, y is equal to a half x squared and y is equal to 2x squared. I'll give you a second to do that. Okay, a few more seconds. Okay, let's get started. So let's work through. Oh, go away. Let's work through this question and this question. Let's do the first one. So y is equal to a half x squared. So my k value is equal to a half. So what's going to happen to the actual curve? We've got a dilation by a scale factor of a half, aka our curve, which might look like this, it's going to be squished. It's going to become a half the height that it actually is. So just really quickly drawing, if this is our original curve, then our new curve is going to look a little fatter. Oops, that looks really gross. Like that. Okay, now let's do y is equal to 2x squared. My k value is equal to 2. So if my curve looks like this, my new transformed graph will look like this. So we have my original function and my new function. Okay? And then drawing it with a graph because it looks a bit nicer. If our original function is in red, so y is equal to x squared, the one that is looking taller will be our y is equal to 2x squared because our k factor is larger. And the one that is looking a bit stoutier and wider will be our a half x squared because it's been squished. Awesome. Okay, and then in terms of what we're missing, we just also need to add our axes. Perfect. Okay, now let's go into asymptotes. Asymptotes are something that are a little bit of an odd thing. So what actually is an asymptote? Let's start with that. I'll give you a second to think about and write down a definition of what you think an asymptote is. Okay, I'll give you like 10 seconds or something. Awesome, I think that's about 10 seconds. So an asymptote is something that pretty much the curve will try to approach but never actually reach. It's like a massive love tragedy that like never ends. Um, so an x asymptote could look a little something like this, where it'll try and approach the y-intercept, but it just never will get there. And then a vertical asymptote could look a little something like this, our exponential graph. It over time will try to reach the y-axis, but it will never reach y is equal to 0. Um, so that's what an asymptote is. So a point where the curve will, approach but never reach. So ways that we can work out the asymptote is to inspect what happens as x gets really large. So you can substitute a massive number, both positive and negative, for your x values into the calculator. My personal favorite, which I just have always used, is 6 times 10 to the 6. It's big enough to make things work. And it'll help you see the direction in which your curve tails. Um, yeah, okay, cool. So an example could be let's do our horizontal asymptote again of the exponential graph. Let's say I just have no idea what the exponential graph looks like, and I definitely didn't just draw it 20 seconds ago. So in our calculator, we can do e to the power of, let's go 300 because, 3 times is even too big. Let's do 30. Um, e to the power of 30 is equal to 13. So what we can write is as x approaches infinity, y approaches an even humongouser number. It's 10 to the power, 1 to the power of 13. So 1 times 10 to the power of 13, which is also infinity. So as we get a huge x number, we get an even bigger y number. Now let's go as x approaches negative infinity. What will happen? So let's go e to the minus 30. I get an absolutely minuscule number. I get 9.4 times 10 to the negative 14. So what I can write is that my y will approach 0. To be a little bit more specific even, I could say that it approaches 0 from a positive side. So what I can write is 0 plus. And what I mean when I say by positive side, if I put into my calculator, I get positive 9.4 times 10 to the negative 14. So it's still a positive number. It's trying to get to 0. It doesn't get to the negatives at all. So it's approaching 0 just from a negative side, which helps me see the actual general curve of the graph to look like this. With an asymptote, because it never reaches 0, but it tries and tries and tries, we have an asymptote at y is equal to 0. Okay? Now we can investigate what happens as x approaches a vertical asymptote. So actually, let's first take a look and see how we can identify a vertical asymptote. The most common way that you can identify a vertical asymptote would be for curves that are reciprocal functions, such as 1 on x minus 2. Okay, that's my example function. I will have an asymptote when my denominator is equal to 0. I'm sure most of you guys have, been like, hey Siri, what's 0 divided by 0? And she'll give a really depressing answer about how you have no friends, and then you start crying about life. But basically, the denominator in a fraction can never be equal to 0. Chuck anything into your calculator on 0, you'll get undefined. So it's just against the laws of physics. So our denominator, x minus 2, can never be equal to 0. So my x value can never be equal to 2 because then the universe will explode. So I'll have an asymptote at x is equal to 2. So I can write, we have a vertical asymptote at x is equal to 2. Okay, cool. So we can actually take a look at what's happening to the curve as we approach these, like this asymptote. So let's take a look. So I've got to draw it a bit more like this. I have my curve, and then I have my asymptote at x is equal to 2. Okay. Calls. Okay. So I'm going to take a look and see what will happen if I substitute just left of 2. So like 1.99999. So we'll go 1 on 1.99999 gets me to like 0.5. Okay. So at x is equal to 1.999, I'm getting 0.5, which I'll put as like over here. Okay. As x approaches 2.000000001, it also approaches a half. Okay, so what my curve might look like. Oh, I'm sorry. I now realize why my thing's not working. It's because I forgot to write -2. Okay, sorry. Let me redo this. So 1.9999999 minus 2. Okay, so on the left-hand side, we're getting minus like 10 million or something. So I can write as x approaches 2, I'm going to write from the negative side. So from the left-hand side, y approaches minus infinity. As x approaches 2 from the positive side, y approaches, let's find out, 1 on 2.0000001 minus 2, like 100 million. So positive infinity. So my curve will look a little something like that. Okay, cool. I am not doing well for time, so I'm gonna kind of hurry up now. So actually drawing the curve. So first recognize the actual type of curve that we've got. So it could be a parabola, a hyperbola, an exponential graph, a log graph. Get familiar with the actual notations for these because it will help you like a quadrillion times more. Then determine actual intercepts and asymptotes. Determine stationary points by doing the first derivatives, points of inflection as well. You may be told if a curve is odd or even, which is something that you went through in year 11. So this, if it's going to be asked, will be given in a question that will be a lot harder than just you have an odd function, draw it. So also keep these in the back of your mind. So an odd function is defined by f of negative x is equal to minus f of x, and even is f of negative x is equal to f of x. So even has an axis of symmetry about the y-axis. So think of like a parabola. Pretend it looks pretty. And then odd has rotational symmetry about the origin. And it must pass the origin as well. Okay? Okay. Cool. Okay, I'm going to give everyone a sec to do this question because it's a really nice question. So draw y is equal to 1 on x squared minus 4. On the same graph, draw y is equal to y is equal to x minus 3. How many solutions does 1 on x squared minus 4 equal to x minus 3 have? Okay, I'm going to give you 30 seconds. Actually, no, I'm going to give you like 10 seconds and then you can pause the video. Yeah. Awesome. Let's take a look. Okay, so this is what the curve. Why does it keep doing that? Please stop, please stop, please stop. This is what the curve looks like. So we have asymptotes at y is equal to x is equal to plus or minus 2. For those of you that weren't sure how to actually draw y is equal to 1 on x squared minus 4, what you're going to do is you're going to go y is equal to 1 on x squared minus 4. Now, the denominator can never, ever, ever be equal to 0, as I was explaining in previous slides. So x squared minus 4 can never be equal to 0. X squared can never be equal to 4. So x cannot be equal to plus or minus root 4, which is 2. So we have asymptotes over here and over here. Okay, next step would be to see what the behavior of the curve is as it approaches these asymptotes. So as x approaches 2 from a negative side, check it into your calculator, you'll get x approaches, y approaches infinity. If it approaches negative 2 from a positive side, you're going to get x approaches negative infinity. Likewise, if we're doing x approaches positive 2 from a negative side, it will get y approaches negative infinity, and x approaches positive 2 from a positive side, y approaches positive infinity. Now, that all sounded like gibberish, so I apologize. And then we have the drawing of y is equal to x minus 3, which I think most people should be comfortable drawing. If you're not comfortable drawing, it is, got a gradient of 1, and we're just translating it 1, 2, 3 places down, and then drawing it. Okay, yeah. Okay, now the actual question is, how many solutions does this have? We have, well, it got cut out, but there's actually a solution over here, one solution over here, and one solution over here. So therefore, we have 3 solutions all up to our question. Okay, here is, oh, okay, never mind, never mind, never mind. Oh, please stop. Okay, sorry. Here's another question. I am not going to go through this question unless we have more time at the end, just because I really want to spend some time on financial maths, and this is all kind of revision for you guys. But this is the question that you can do in your own time. Okay? All right. So just a reminder that we won't really have any Q&A breaks or anything. So I'm going to give you a 20-second moment to take a sec, pause the video if you need to write some more, and write as many questions as you have down below in the chat. Okay, so whatever, it could be on graphing, it could be on uni, it could be on the HSC, it could be on ATARs, it could be on whatever you wanted to ask me, could be about vet, whatever you've got, write it down below. Okay, if you need more time, pause the video. I'm going to move on. Okay, so a halfway health check. So I would like you guys, whilst you're still down at the Slido poll, answer these 4 questions down below. So where do you want to be by the end of the year? Second question, are you happy with where you're at the moment? What do you need to get where you want to be? And what is keeping you from getting there? Okay. Once again, because we're a bit short on time, I want you guys to just pause this video and do this. It's something that I think is super duper important for you, like probably one of the biggest takeaways from this lecture. So please pause this video and do this. Okay, I'm going to move on. Okay, so what I've received a lot in previous health checks is I'm not comfortable with my study. So create a study timetable. We have an actual template on our ATO Notes website. So take a look at that. I've got the PDF of the slides, by the way, I think it's on the right-hand side. So you guys have access to everything that I'm doing right now as well. Use a to-do list to make your study, make sure your study has a purpose. It's something that I, to this day, live by, as I was talking about earlier. Um, Mix it up. So don't just do homework, 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 or just do practice paper, practice paper, practice paper. Oh, that's a tongue twister. Um, do a little bit of everything so that you can like actually find some joy in studying. I know it's a bit hard sometimes. Also, I think Smash HSC was on Thursday. But yeah, check out the Smash HSC lecture as well. That is literally a 2 hour time slot that's just going to be talking about stuff like this. So I'd highly recommend. Um, and I don't understand the content. That's also a big one. So pretty much for moments like this, you you have to kind of go back to quotes like you need to learn how to crawl before you can run and stuff like that. But it's honestly so true. So if you can't really start doing complex stuff until you can actually build your foundation, because then you'll just have gaps in your knowledge and that you won't be able to fill without actually going back. So especially while you're in on the holiday in while you're on holidays, you I'd highly recommend just going back to the actual basics. So if you weren't too good with graphing, and you're expected to do inequalities questions like the one that I didn't actually go through because that was for you guys to do on your own time, stuff like that. You won't be able to do an inequalities question like that unless you're able to actually graph quite confidently. So things like that, you'll need to learn your foundations before you can build and build and build. Okay, so make sure you go back to the basics before you're expected to, fly. And try and have it explained in different ways is also a massive one. So if you're anything like me, sometimes your teachers aren't the best at explaining something, and then they don't really know how to explain it a different way. So your textbook, your friends, especially awesome resource for you, your friends, your best friends. Um, and then like YouTube videos. Pretty much everything that you learn in the HSC is also on YouTube. So that as well. And obviously just asking more questions. So your teacher, if you have a tutor, then your tutor. Your siblings, any other past HSC students that did the same subject as you. I am quite definite that there are a massive team of people that would be more than happy to help if you ever asked for it. Okay? Okay, I don't feel good about exams. This is a massive one that everyone talks about every single like holiday. And I think most people don't feel good about exams. I think that's quite common. But it's definitely all about practice. So everything you do should be marked. Everything you do should be under time as well. Okay. And give yourself less time to do it as you get more and more confident. So the Maths Advanced paper is 3 hours, but I always aimed to finish it before 90 minutes. Normally, I'd get it done within an hour. Um, Obviously, that's something that you need to like work on, but obviously, it's not necessarily a speed game. You don't need to sit the HSC 3 times, because the 3 hour exam doesn't need to be written in 60 minutes. But yeah, once you practice with your practice papers, you'll get to the point by the time, maybe for your trials, but definitely by the time you get to the HSC, where what you're like you're doing so many practice papers to the point that when you go sit the HSC, you maybe have a little bit more nerves than normal, but it will pretty much just be another practice paper, another past paper. That's all it'll be. Yeah, so once you get to that stage, you're pretty good with life. Okay, next question is I'm not happy with my results. So analyze where you have gone wrong. You can talk to someone about it, obviously, but also know that it's not the end of the world. Reflect upon what you've gone wrong, what you've gotten wrong. Something that I know my friend did was have like a mistakes diary. Do whatever you need to kind of stop yourself from making those kinds of mistakes again, so that you're actually growing, learning, maximizing everything needed to make things better. Okay, and then the big one. I don't feel motivated. You're definitely not alone. So some things that you could try is stick up some inspirational quotes on like your phone wallpaper or the wall behind you. Um, there were some very nice quotes from a lot of inspiring people. So there's always something that's going to make you feel a lot better. Try the Pomodoro technique. I personally didn't use it because it didn't work for me. I was someone that once you get into stuff, I'm like focused, which the Pomodoro technique, 25 minutes on something just isn't enough for me. Whereas m most people, I feel like the Pomodoro technique will work good for you and it'll keep your like actual engagement high. So the Pomodoro technique, for you, those of you that don't know, you can obviously Google it, but it's basically 25 minutes of study, 5 minutes of break. 25 minutes study, 5 minutes of break, 25 minutes study, 5 minutes of break, and you just keep going until your study time's up. So yeah, that's also probably one of the most popular studying methods. So also something to try if you haven't tried already. Um, this one's big. Figure out which times of the day you are most productive. For me, it was really early morning. So I personally am someone that would be productive if I wake up at 4 a.m. or 5 a.m. Um, which is so annoying because who the heck wakes up at 4 a.m. and like studies? That just sounds like psychotic. But if I was studying for exams, if I was studying for the HSC, it is something that I did because by the time we get around to like 4 p.m., I'm ready to like go to sleep. Well, not go to sleep at 4 p.m., but like my brain would not be working at its full capacity. So just something to keep in mind. Find the time that works best for you and try your best to leverage those times of the day. Um, give yourself a reward when you finish studying. For me, it means having a PlayStation with my cats because um, that's like the highlight of my day, or watching a TV show, or possibly five because I was super productive that day. Up to you. But yeah, find something that's rewarding, having a piece of chocolate, whatever it is, so that you actually feel a bit more fulfilled. Okay, now onto the second part of this lecture. I may not finish everything on here. I will try my very best to, but financial maths has some lengthy questions, so I'll get to whatever I can get up to. Just a heads up. Okay, arithmetic sequences and series. This is the first part. So, what is an arithmetic sequence? Basically, an arithmetic sequence is basically when we're adding terms together and they differ by a constant amount. So 1 plus 4 plus 7 plus 10, which has you're adding 3 and adding 3 and adding 3. So your constant like difference is 3. Another one is minus 3, minus 5, minus 7. So that would be, minus 2, minus 2 again. So my constant difference is minus 2. Um, and then I know I keep saying sequences and series. You might not know what a sequence or a series is. So sequences and series pretty much the exact same thing. A sequence is when they're being added together. A series is just when they're listed next to each other. So the example being 1, 4, 7. It's not 1 plus 4 plus 7 plus blah blah blah. It's just 1, 4, 7. That's the only difference. Okay. So just some more terminology. A is known as the first term. So when I get to the equations, A is the first term, T1. Okay, Tn means the nth term, and it will be equal to whatever the last term was plus the common difference. Okay, I feel like this will make more sense once I actually go in with an actual question. So let's go in with the actual equation first, and then we'll go through the questions. Okay, to find a certain term, we have the formula Tn is equal to A plus n minus 1 times D. So A, as I was saying before, is the first term. N is the number of terms, so the nth term. And then D is the common difference between the terms. Yeah, and then we're just going to prove that formula for you. So if we know that A is T1, then T2 will be T1 plus whatever the common difference is. So A plus D. T3 will be T2 plus D again. So A plus D plus D. So A plus 2D, which if you just keep going until whatever n, you'll still be boiled down to the same formula. Tn is equal to A plus n minus 1 times D. Okay, so that's also on your formula sheet, by the way. With this in mind, let's try this question. I'm not going to give you any time to go through it on your own, so you can pause if you'd like to go through this. Okay, so Bockham Hills 2018. In arithmetic progression, T2 is equal to 7, T7 is equal to 53. Find the common difference and the first term. Okay, so I'm going to write the equation at the top. So Tn is equal to A plus n minus 1 D. T2 is equal to A plus 2 minus 1, which is just 1, times D. Okay, so I can write that A plus D is equal to 7. Okay, what else can I write? I can write that T7 is equal to A plus 7 minus 1, so 6D, which is equal to 53. So what I'm going to do is I mean, you can choose what you'd like to do with this. You're going to have to do simultaneous equations. I'm going to define D. Actually, no, I'm going to define A. You can pick, won't make a difference. So A is equal to 7 minus D. Okay? So now I'm going to sub A is, well, basically sub 1 into 2. So T7 is equal to 7 minus D plus 6D is equal to 53. 7D is equal to, oh, not 7, sorry, 5D. 53 minus 7. 46. So D is equal to 46 on 5. 9.2. Okay. Sub D is equal to 9.2 into the first equation. So A is equal to 7 minus 9.2, which is negative 2.2. Okay, and now my next step is to obviously check. So check by subbing into A. Oh, sorry, 2. So I get minus 2.2 plus 6 times 9.2 is equal to 53, which is correct. So my A and my D. Okay. The next question is to find the value of the first term and the series, which is greater than 1,000. Okay. So let's do the actual equation first. So Tn is equal to A, so negative 2.2 plus n minus 1 times 9.2. I'm actually going to expand these brackets. So it's going to get me to minus 2.2 plus 9.2n minus 9.2, which will get me to 9.2n minus 11.4 is equal to Tn. Okay, so I'm looking for the term value that'll be greater than 1,000. So I'm going to say that 1,000 is equal to 9.2n minus 11.4. 9.2n is equal to 1,011.4. N will be equal to 101.4 divided by 9.2. Which will be 109.93, blah, blah, blah. So my next thing is to check what the question's actually asking for. Is the question asking for what's greater than 1,000? So I'm going to sub in 109 into my Tn. 109 will get me 9.2 times 109 minus 11.4. That gets me to 991. We're not there yet. We're not at over 1,000. So if I go to 110, I should be, yeah, 1,006. Okay. So therefore, n is equal to 110, but that's not answering my question. The question wants me to know the value of the first term. T 110 is equal to 1,000.6. And that's how we answer this question. Awesome. Let's move on to the sum of the n terms, which is given by these equations, also given on your formula sheet. So Sn is equal to the number of terms on 2 times a plus l. So the first term plus the last term, which is proven in a really cool way. I'll show it to you in the next slide. And from this equation, we can derive this equation, which is also given in the formula sheet. Okay. So the way that this formula was derived is there was this German mathematician, which I can't remember his name, but he pretty much just defined the sum of n numbers to be, term 1 plus term 2 plus term 3 plus term 4 plus blah, 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 which will be, a plus a plus d plus a plus d plus d, and so on, so on, so forth. And then obviously, because they're all being added, if you just flip them over, it'll be the same thing. And then when you add these together, so 2Sn, you'll find that everything cancels with each other except for our a plus l. So you're left with just Sn is equal to n on 2 times a plus l. So that's a pretty cool formula. Okay, so we have a question, also from Bottom Hills. Chris is making a pattern using triangular tiles. The pattern has 5 tiles in the first row, 7 tiles in the second row, and each successive row has 2 more tiles than the previous. How many tiles would Chris use altogether to make his first 25 tiles? I'll give you a sec to pause this question and work through this on your own, okay? Okay. Hopefully you have done the question now, and I'm going to show you the working. Awesome. Okay, so the first tile, so T1, is equal to 5, and our common difference is equal to 2. So Tn is equal to 5 plus n minus 1 times 2, which is equal to 5 plus 2n minus 2. So it's equal to 2n plus 3. Okay? Which I suppose I didn't even need to do, but I did it anyway. Okay, now we'll do the sum of 25. So there's 2 ways that you could do the sum of 25. It could be first doing this and then doing the first equation, which is Sn is equal to n on 2 a plus l. My personal favorite, but you'll need to know how to use both equations. So let's check all our variables. So n is equal to 25. We don't have l though, so we'll need to use this equation to find l. So T25 will be equal to 2 times 25 plus 3, which will be 53. Okay, so L is equal to 53. So we can write 25 on 2, 5 plus 53. Wish my brain couldn't tell me what the answer is. That is, so we'll go 25 on 2, 5 plus 53. That's 725. Another way that we could do this is by putting it directly into our second equation, which is Fn is equal to n on 2, 2a plus, I think it's minus 1d. Yeah. Okay. So n is 25 on 2 times 2 times a plus 24 times 2, which will get us to, just in case I made a mistake with my working. Awesome, 725. Okay, so it depends on the situation when you want to use what. A lot of the time you could use either one. But just so you know, even though this equation is a little bit nicer, this one requires less steps of working. So it's whatever suits you best, and obviously whatever the question gives you the circumstances for. But you should know how to comfortably use both, ideally, by the time you get to your trials. Okay. Oh, now we have geometric sequences and series. So just before we had arithmetic. Geometric's about the same thing, except instead of adding new things, so instead of it being like 1, 3, 5, 7, where you add 2, add 2, add 2, add 2, this time it'll be something like 1, 2, 4, 8, 16, 32. So it'll be timesing by something instead of adding. Okay, so that's the difference. Instead, we have a common ratio. So instead of having our D, we have a new variable called R. Okay, apart from that, everything else is about the same. Okay, so the new equation for Tn is A times R to the power of n minus 1. Okay, A is the first term, R is the common ratio, and n is the number of terms. Okay, the proving for this equation is that the first term, obviously A. The second term will be T1 times R, so AR. The third term will be T2 times R, so A times R, which is AR to the power of 2. A4 will be AR cubed, and so on and so forth, which just leaves us with our final equation, which is Tn is equal to AR to the power of n minus 1. Okay. Okay, I'm going to give you a sec to pick whether the answer to this question will be A, B, C, or D. Okay, let's go through this question. All right, so my first term, my A, is equal to 3x. I don't actually know what my common ratio is, so let's work that out. The way that we can work it out is I can divide T2, so R is equal to T2 on T1, which will be equal to T3 on T2, which will be equal to T4 on T3, and so on and so forth. So it'll be equal to 6x squared on 3x, which is just 2x. Oh, sorry, negative 2x, because it's negative 6x squared. So R is equal to minus 2x. Okay, so let's do the 10th term. Okay, so T10 will be equal to AR n minus 1, which will be 3x minus 2x to the power of 11. Okay, which will get us to 3 times, I don't know what 2 to the power of 11 is, minus 2048 times x to, oh, why did I do 11? That's supposed to be 9. Oops. Let's go back. Times 512 times x to the 10. Okay, 3 times 512 is 1536, or negative 1536 times 10 to, oops, times x to the 10, which isn't even an option here. So let's do T11 is equal to 3x times minus 2x to the power of 10, which will be 3 times 2 to the 10, 1024, times x to the 11. So 3 times 1024 is 3074x to the 11. So my answer is C. Hopefully you guys got that. Okay, then we have the sum of the geometric series, sorry. So it's given by these two equations. These two equations are the exact same thing because pretty much they're just in the opposite direction on both the numerator and the denominator. So it'll be a negative on a negative, which cancels each other out. Both formulae are the same, but it's easier to use the first one, this one, when r is a small number. So it's more so when the absolute value of r is a small number. And then the second equation, this one, when r is a larger number. But you can use either or. Okay. I'm not going to bother with the explanation for this one. Okay. Then we have another equation, and this is called the limiting sum of a geometric series. It sounds super fancy, and it is kind of fancy, but basically, when r is a small number, let's say r is equal to a half. I want you guys to put in your calculator what happens when r is a small number. So, let's say we have a half. Okay. Pretty much what happens is we very quickly get a really, really small number. So in the end, we'll basically have this like opposite of exponential decay. But yeah, exponential decay, where it'll pretty much at the end become so tiny that it'll basically be zero. So the value of the sum of all these terms can be found using the equation S infinity is equal to A on 1 minus R, so long as R is a number smaller than 0, smaller than 1, sorry. Okay, I think I've got a question on that. No, I don't. Yes, I do. Okay. Here's the question. So a geometric series has a first term A and a limiting sum 2. Find all possible values for A. It's slightly disgusting. I'm going to go through this now. So S infinity is equal to A on 1 minus R. Okay. Which will be equal to 2. Okay. So now let's bring A to the, like A and 2 on the other side so that we can make R the subject. So A on 2 is equal to 1 minus R. Okay. So R will be equal to 1 minus A on 2. Okay. But the absolute value of R is less than 1. So I'm not sure if that's just the final answer or not. I'll need to check actually because I don't think I've done this question myself. But yeah, I think this could possibly be an answer, but I think there could possibly be more work into it. So I'll get back to it at the end if I get enough time. Okay. I have another question for you guys. So, in an arithmetic series, the fourth term is 6, and the sum of the first 16 terms is 120. Find the common difference. Okay, I'll give you a minute to do that on your own. Jokes, I'm just going to make you pause so that we can hurry up and get everything done before the time's over. Okay, so let's do this. So the fourth term, T4, is equal to A plus 3D equals to 6. Okay, and the sum of the first 16 terms, so S16 is equal to 16 on 2, 2A plus 15D is equal to 120. So 2A plus 15D is equal to 120. Can 120 be divided by 8? It can be, cool. So 2A plus 15D is equal to 15. Okay, I am going to make A equal to 6 minus 3D, and I'm going to sub into there. So 6 minus 3D plus 15D is equal to 15. 12 minus 60 plus 15d is equal to 15. D is equal to, so 15 minus 12 divided by 11, 3 on 11. Okay, and then my first term will be equal to 6 minus 3 times 3 on 11. Oops, 11, which gets me 6 minus 9 on 11, 57 on 11. Okay, cool. All right, awesome. Now let's get into financial mathematics, which I have put on a very low pedestal for you guys because I talked about how disgusting it was. But I'll be honest, as disgusting of a topic it is, by the time I got to the HSC, it is the one that I was pretty much most confident in because I'd done enough practice questions and I'd made sure that I understood it well, to the point where I was like, yes, make the whole exam on financial maths because I'll get like full marks. Okay, so go about financial maths as though you're wanting to absolutely bliss it. Okay. Keep practicing, keep going at it, no matter how much you hate it, because obviously the more time you spend on it, I suppose hopefully the more you love it. Okay. So going back to, I think it was like year 8 or year 9 where you learned about compound interest. And A is equal to P 1 plus R to the power of N, where P is the principal, the original amount of money that you borrowed. A is the like future value. And also just noting for N, um, they'll give you like N and R actually even. So they'll like say that something's being compounded weekly or monthly or annually or quarterly or biannually or whatever. So let's say that you've got a question where it's like 6%. Actually, no, let's make it a bit easier. Let's go 12% per annum compounded monthly. Now our R and our N will be relative to our monthly part, okay? Even though the percentage is per annum. So N for a year will be equal to 12, okay? And R will be equal to 1 plus 12% on 12 months because we're doing monthly. So it'll be 1.01 as opposed to like 1.12, right? Okay, just something to keep in mind as I move forward to a question. Okay. So here is the question. So a table shows the future value of an annuity of $1 for different interest rates for 4, 5, and 6 years. The contributions are made at the end of each year. Here's the future value of an annuity table. An annuity account is opened and contributions of $2,000 are made at the end of each year for 7 years. For the first 6 years, the interest rate is 4% per annum compounded annually. For the seventh year, the interest rate increases to 5% per annum compounded annually. Calculate the amount in the account immediately after the seventh contribution is made. I'm going to give you a sec to do this one because it's definitely a tricky question. And for those of you that haven't done this yet, that's okay because I'll go through everything. Okay. Most of you guys would not have finished this question yet, but that's okay. I'm going to get you to pause and complete it right now and then come back once you are done. But I'm just going to get my OneNote because there's a lot of working and not enough space. Okay, let's try that. I don't know if this will be helpful. We'll find out. Okay, so firstly, I'm going to take a look at the table for the first part of the question. So for the first 6 years, the interest rate is 4% per annum. Okay, and it's for the first 6 years. So I'm not sure if you guys have used annuity tables before. I think it was touched on in like year 10. I don't know if you guys have done financial maths yet, but basically annuity tables are really, really nice. And what you need to do is you just need to take a look at the principal amount, how much you are like contributing. And in this case, we're contributing $2,000 each month, and we're just going to times it by this amount. So times 6.633, which will be equal to $13,226. Okay, so that's how much money you have in the first 6 years. But then they add a little twist to it. They're like, on the seventh year, the interest rises to 5% per annum compounded annually. Now, there's one problem with this. There actually isn't a 5% column. So I'm going to teach you what we could do to do this. And it's just using the simple, well, I can't say simple, the compound interest formula, which is, you know, A is equal to P 1 plus R to the power of N, right? Um, so N, actually, so this is the amount till 6. A7 will be our P 1 plus R to the power of N. In this case, P is going to be A6. Okay, so whatever we have in our like as our final amount using our table, so our last step. So it'll be 13,226 times 1 plus 5% because we're compounding annually to the power of 1. Okay, which will be times 1.05. Okay, dollars 13,929.30. Now that's how much interest has been paid on the seventh year. However, I haven't included the final contribution that they make at the end of the year. So I'm going to add another $2,000. So my final answer is $15,929.30. That's how much whatever this dude's name is makes after 7 years. Okay. Cool. Let's move forward. Okay. A reducing balance loan. Let me get back to the big page. Okay. A reducing balance loan. It's a little bit less expensive than a flat rate loan. But basically, as the balance owing decreases when you're like taking out a loan, the interest charged each period also decreases. Okay. And it involves the use of like geometric sequences and series, and it can get a little bit complex. We've got a couple of questions. We're getting towards the end of this lecture, but these last few questions will take a while to go through. So let's go through a question. So Bianca borrows $650,000 to be repaid over 20 years at an interest rate of 4.2% per annum, reducible monthly. Um, Let M dollars be the monthly repayment and AN be the amount owing at the end of the at the end of the where am I? Sorry. At the end of the N months after the repayment has been made. So the first question is to show that A2 is equal to 650,000 times 1.0035 squared minus M times 1.0035. Okay. Um, for a lot of you guys, this would mean absolutely nothing, right? So let's go through this. Okay. Let me escape. Okay. Cool, 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 cool. So this is like slide 72 or 73. Okay. So the very first step is to just take a look at all of our variables first, right? So our principal is $650,000. Our interest rate, so the 1 plus R part, 1 plus R will be equal to 1 plus 4.2% on 12 because it's compounded monthly. Okay, so that will be equal to 1 plus 4.2% on 12, which is 1.0035. Okay, and then our N. So it's going to take her 20 years, but N is in months. So 20 times 12 months is 240 months. Okay, I think that's all that we need at the moment. Let's get our actual loan repayment started. Okay, so I'm going to go through things. I'll try and go as slow as I can, and make as much sense of it as I can. But please watch intently for the next few minutes because this is all brand new info to you guys. So I'm going to write the A0 being my principal. So the amount initially is my principal, which is $650,000. Sorry. Okay, my A1 will be equal to my A0 times my interest rate, right? So 1.0035. And then at the end of every month, she pays off her repayment. So minus M. So it will be equal to 650,000 times 1.0035 minus M. So I just replace my A0 with what A0 actually is. Okay, now let's move on to A2, which we're going to follow the same pattern. So A2 will be equal to A1 times 1.0035. And then at the end of the month, we're subtracting M. Okay, so it will be equal to 650,000 times 1.0035 minus M, all times 1.0035 minus M. Okay. Now I'm just going to expand that out. So times the 1.0035 to this and to this. So that gets me to 650,000 times 1.0035 squared minus M times 1.0035, and then chuck the minus M over here as well. So minus M. Now, that isn't the full way that these guys have written it. They've written it as like this is the same, but on the side over here, they take m out as a common factor. So it'll be 650,000 times 1.0035 squared minus m. I'm going to put this one to the front, so it'll just be 1 plus 1.0035, okay? Which is exactly what I asked for. So that's for I. Let's move on to II. II says show that a n is equal to 650,000 times 1.0035 to the power of n minus m times this weird looking bracket that says 1.0035 to the power of n minus 1, all on 0.0035. So the way that you could first approach this is by continuing this pattern a little bit more. Let's go to A3 and see what happens. Can we start to see a little bit more of a pattern forming? So A3 is equal to A2 times 1.0035 minus m. Okay, so it's equal to 650,000 times 1.0035 squared minus, I'm going to go back to the original notation of it being like m minus 1.0035 m, all times 1.0035, all minus m. So that gets me to 650,000 times 1.0035 cubed minus 1.0035, well, m times 1.0035 squared minus 1.0035 m times minus m. And this time I'm going to take out my common factor of m again. So 650,000 times 1.0035 squared minus m, 1 plus 1.0035 plus 1.0035 squared. Okay, so let's take a look at what happens. So the first time, it's just minus m. And the second time, it's minus like 1 plus 1.0035. And the third time, it's 1.0035 plus 1.0035 squared. So each time that we're going around, we're adding a new term, and the next one would be 1.0035 to the power of 3, right? And it'll keep going like that. So what I'm going to do is I can extrapolate what it'll look like at an. So an will be equal to 650,000 times 1.0035 to the power, oh, sorry, that's supposed to be a 3, of n, because let's take a look. So when a is 1, the power is 1 over here. When a is 2, the power is 2 over here. And when a is 3, the power over here is also 3. So we're following that same kind of pattern. And then on the right-hand side, it'll be minus m, 1 plus 1.0035 plus 1.0035 squared plus blah, 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 plus 1.0035. The power, let's take a look at the power. So when n is equal to 3, the greatest power on this over here is 3 minus 1, 2. And same over here, when a is 2, the greatest power is 1. So it'll be n minus 1. Okay? All right. And now let's take a look at how we can possibly make it look a little bit more like this. We've got the left-hand side part like pretty much down packed, like to the dot. The right-hand side, not so much, because we need to notice something. And the thing that we need to notice is that we have a geometric series at our hand. You can see that each time we're multiplying by 1.0035. Okay. Um, so with that in mind, I could say that my first value, my A, is equal to 1. My R is equal to 1.0035. And my N, the number of terms that I have, will be equal to, so whatever the highest, well, a lot of people will think that it's just whatever the highest power is. In this case, it wouldn't quite be because um, I've got like to the power of 1, to the power of 2, blah, blah, blah. And I have an invisible times 1.0035 to the power of 0 that I need to take account for. So my N is just equal to N. Okay, so my AN will be equal to 650,000 times 1.0035 to the power of N minus M times, let's do our sum of geometric series formula, which is Sn is equal to A Rn minus 1 on R minus 1. Okay, so 1 times R, 1.0035 to the power of N minus 1, all on 1.0035 minus 1. Okay, and that's going to get me to 650,000 1.0035 to the power of N minus 1.0035 to the power of N minus 1 on 0.0035. And that leaves me exactly as the question asks for. So I've just proven, or more so shown, that AN is equal to 650,000 times 1.0035 to the power of N minus M, that fraction. Okay? Okay, now the next question is kind of tricky. It says find the value of M. That's a bit tricky. Like, what am I supposed to do? How do I find the value of M? The way that we go about this is by taking a look at the first part of the question. The first part of the question says that she is going to repay it by 20 years' time. Okay, so what I can write is that A, 240, because we're going in monthly repayments, right? Which will be equal to 650,000 times. By the way, because I've got my rule here, I can apply that for any value of N. So times 1.0035 to the power of 240 minus M, 1.0035 to the power of 240 minus 1 on 0.0035. Okay? And that, my dear friends, will be equal to 0 because A, whatever, is the number of money, like the amount of money owing at the end of N months. So at the end of 240 months, at the end of 20 years, she should have fully repaid it. Sorry. So the amount owing, $0. So now we're just going to solve for N. So I'm going to put this into my calculator because it looks a bit disgusting to try and do it algebraically. So 650,000 times 1.0035 to the power of 240, which gets me to 150,3432.015 minus M times 1.0035 to the power of 240 minus 1 on 0.0035. So 375.13 blah 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 blah. I'm going to solve for M, so I'm going to bring this over to the other side. So M times 375.134 blah 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 is equal to 150,3432.015. Going to divide this over to the other side to get my answer that M is equal to 4,007.71. So each month, Bianca has been paying $4,007.71 to the bank. Okay, that's question I. And lucky last question IV. Question IV says, after making 120 repayments, Bianca decides that she wants to pay off the loan more quickly so that only 5 more years of repayments are needed. How much does she need to increase the value of her monthly repayment? Okay, so this is a bit annoying. I mean, it's going to be good for her, but it's going to be annoying for us bankers because now we need to do more maths. Okay, so pretty much what we need to do is we need to find the amount owing at 120 months. And what that's going to help us do is we're going to need to make a whole new pattern for whatever happens after 120 months. So first, let's do A120. A120 is equal to 650,000 times 1.0035 to the power of 120 minus, we now have m, so 4007.71 times 1.0035 to the 120 minus 1, all on 0.0035. Okay, so the amount owing will be, give me like a sec. Okay, so it'll be $392,150.02. Sorry. Cool. Um, so that's how much is owing in after 120 months, as I said like 20 times already. So what I'm next going to do is, because I need to make a whole new pattern to like figure out how much she needs to pay now, I am going to pretty much make this value my new P, so my principal. And so now our A0, I'm going to put in like quotation marks almost, it'll be equal to $392,150.02. So A1, we're going to go through this whole pattern making shebang again. So A1 will be equal to A0 times 1.0035 minus M. Okay, so that'll be equal to 392,150.02 times 1.0035 minus M. A2 will be equal to A1 times 1.0035 minus M. So that will be equal to 392,150.02 times 1.0035 minus M, all times 1.0035 minus M. Expand the brackets, and that gets you to 392,150.02 times 1.0035 squared minus 1.0035 m minus m. I'm going to do the same thing that was done in here, sorry, and I'm going to put the m out the front and like put it in brackets to make things a bit nicer for me in the future. Oops, going too far ahead. Minus 1.0035, oops, sorry, minus m1 plus 1.0035. Okay, A3 will be equal to A2 times 1.0035 minus m. Okay, so that's going to follow that same pattern. So 392,150.02 times 1.0035 cubed minus m1 plus 1.0035 plus 1.0035 squared. Okay, now I'm going to extrapolate what my an is going to look like. Okay, so that will look like, let's take a look at our powers again. So when a is equal to 3, our highest power is equal to 3. Same thing happens at 2 and same thing happens at 1. So for the first part, I can write 392,150.02 times 1.0035 to the power of n. minus m. Over here, we have our a being 1, our r being 1.0035, and just like before, our n is equal to n. So it'll be 1 times 1.0035 to the power of n minus 1 on 1.0035 minus 1. So it'll be equal to 392,150.02 times 1.0035 to the power of n minus m 1.0035 to the power of n minus 1 on 0.0035. Okay, so to actually answer the question now, we only need 5 more years. So n in this case, after 5 years, will be 12 times 5, sorry, not 6, which will be 60. So A60 will be equal to 392,150.02 times 1.0035 to the power of 60 minus m 1.003560 minus 1 on 0.0035. And now here's the thing. Just like before, when if she wants to have it finished by 60 months, then the amount owing at the 60th month should be $0. So A60 at the end of the 60th month should be 0. Okay. Now we just need to solve for m. So let's do that. So 1.0035 to the power of 60. That is 483,609.53. Or we'll go 525252, just so I don't make a calculator mistake later. Minus m times 66.35, blah, 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 which will be equal to 0. I'm going to bring this to the other side, like so. So my m will be equal to 483,609.52525252. Okay, so her monthly repayments will increase to 7,257.49. Okay, that's how much it'll be increasing to, but that actually doesn't answer the question. The question actually says, by how much does she need to increase? Okay, so to properly answer the question, let's take a look at her initial amount. It was like $4,007.71. So she increases by 7,257.49 minus 4,007.71, which is minus 4,007.71, 3,249.78 per month increase. Okay, so I know I didn't get the opportunity to properly go through a lot of questions for financial mathematics. Unfortunately, I won't be able to go through these 2 questions, but I would highly recommend trying to go through these, even if your school hasn't gone through this kind of stuff yet. Just by maybe re-watching my example that I just went through and kind of getting used to the steps so that you can work out questions 2 and 3, because it's going to be awesome if you're able to actually answer these kinds of questions before your school actually gets to it. Yeah. Okay. But in terms of today, that will be it for me. I'll still be around for a few minutes to answer Q&A, so please keep asking questions, and I'm more than happy to answer them. But apart from that, I wish you all the very best for the rest of the second half of your HSC, and I'll probably see you next holiday lectures. All right, thank you.